What's up guys, and welcome to this new episode dedicated to Superbase. In the last video, I have given a brief explanation about the MVVM architecture and how its different components work together. And in this video, I will try to explain all about dependency injection and the inversion of control, or EOC. We also try to see what is the difference between manual dependency injection and dependency injection using a framework such as Hilt or Coin. And finally, we will set up Hilt, and then I will walk you through some components that Hilt provide for dependency injection. With that said, let's get started. So what is basically dependency injection? Well, I will try to explain that concept using this example here. So as you can see here, I have two view models, the view model 1 and the view model 2. Those two view models has one thing in common. Both depend to the repository. But the difference between the view model 1 and the view model 2 is the fact that the view model 1 created the instance of the repository inside the class itself, but the view model 2 creates the dependency, or the instance of the repository will come from the outside. So that is the difference between those two classes. So for the view model 2, we can say that the dependency of the repository will be injected from the outside. But for the view model 1, we don't need to inject that dependency because it already exists inside the class. So you may wondering, well, so what is the difference, or what is the advantage of using the first approach instead of the second one, or using the second one instead of the first one? Well, there is a big problem with the first approach. The fact that the dependency is created inside the class itself, it makes this class not reusable. But for the view model 2, it's much more flexible, and I will tell you why in a couple of moments. One reason that I have said that the view model 2 uses an interesting approach is the fact that every time you need to create an object or an instance of the view model 2, you will need first to create an instance of the repository. So in that case, you will explicitly see that there is a dependency between view model 2 and the user repository, because every time you will need an object or an instance of view model 2, you will probably need to create an instance of the user repository. But it's not the case with the view model 1. Why? Well, because you can create an instance of view model 1 without even noticing that the view model 1 depends to the user repository, even though that dependency exists. That is why it's super interesting to inject the dependency from the outside. And the concept of injecting the dependency from the outside instead of creating that dependency inside the class itself, it's what we call dependency injection. One reason that makes the view model 2 interesting is when you try to think about testing. And one principle that we used to follow when it comes to test a new component is to replace all its dependencies with the fake implementation of those dependencies. So it means that every time I need to test the view model 2, I will need to replace this user repository with a fake implementation of the user repository. So it can be a mock, it can be a fake object or a stub or whenever. But it will not be the case for the view model 1. Why? Well, because the dependency of the view model 1, it's already created from the inside of the class itself. So there is not a way to replace that particular dependency with a fake one. But for the view model 2, it will be much more flexible because the dependency will come from the outside. So it means that at each point, I can create the real implementation and pass it to the view model 2, or I can create a fake or a mock and pass it to the view model in order to be able to test that component correctly. So that is the main reason, or another reason, that is really important to use dependency injection when you are creating an application that is supposed to be strong enough and to be much more testable. I have said recently that the view model 2 offers the flexibility of injecting the dependency from the outside, and that will allow us to replace, let's say, this real implementation of the user repository with a fake one when it comes to test the view model 2. Let's try to play the view model 2 first. I will create an object called VM, and as you can see, I got a compilation error here because I need to provide an instance of the user repository in order to be able to create the view model 2 object. So I will create a repo object here of type user repository, and then I will pass this object to the view model 2. Now everything worked perfectly. Now let's say I want to test the view model 2. In this case, I need to replace this user repository that contains the actual implementation of the business logic related to the user with this fake implementation here. So first, let me create the fake repo, right? And let me try to pass it to the view model 2. As you can see, I got a compilation error here. Why? Well, the reason is quite simple and obvious, because the fake user repository and the user repository don't share anything in common. They don't even inherit from the same class. So it means that the view model 2 only accept the instance of the user repository and doesn't recognize any instance from the fake user repository. So you may ask me the question, so how to make the view model able to accept both an instance of the user repository and an instance of the fake user repository? I will try to explain it in a couple of moments. In order to make the view model 2 compatible with both the user repository and the fake user repository, I need to make both classes sign the same contract. And in object-oriented programming, the concept of contract can be implemented by using an interface. So I'm going to create an interface here that I'm going to call, let's say, a repo, right? And I will make the fake user repository to implement that interface. And I will do the same thing for this class here, right? And now the user repository and the fake user repository have something in common, the repository interface here. But I still have this compilation error here because it's pretty obvious that the view model 2 still depends on the user repository. And in order to make the view model 2 to be compatible with both the fake and the user repository, I just need to replace this user repository with the repository interface. So in this case, by doing that, you will see that this compilation error here just disappear. I don't have the compilation error anymore here because the view model 2 take the dependency of type repo, the interface that I've just created. And as soon as an object or a class implement the interface repo, the object that I'm going to create from that class will automatically be compatible with the view model 2. Because by inheritance, I can say that the fake user repository is a repository, and I can do the same thing for the user repository. And also, I can create a new class, and as soon as that class implements the repo interface, that class will be automatically compatible with the view model 2. As you can see, the view model 2 doesn't hold any dependency to a class, but instead it's hold a dependency to an interface. And in object-oriented programming, an interface is what we call an abstraction, because by nature, an interface is not supposed to hold any implementation detail. And as you can see here, when I'm defining the view model 2, I don't know the exact object, the exact class that will be passed to the view model 2, because it can be anything as soon as it implements the repo interface. But when I'm using the view model 2, I know the exact object that will be passed to the view model 2. And that concept is what we call the inversion of control. Because when I'm using the view model 2, I know the object, the exact object that will be passed to the view model 2. But when I'm defining the view model 2, I don't know exactly which type of object that will be passed to the view model 2. I don't know the exact type of the object that will be passed to the view model 2. And that's what we call the inversion of control. And by replacing the dependency of a class by abstraction, you are doing what we call the inversion of control. I know that it can be tricky, but it's a really interesting concept that you can dig in by the link that I have put in the description below. Now I think you have more or less a good understanding of what is dependency injection or inversion of control. But there is another point that I think it's very important to cover here. So you can see that the view model 2 is relatively simple and take only one dependency. But in reality, the component used to have a lot of dependency. Not basically one. It can be 2, 3, 10. It depends on the size of the application. And it means that, let's say this view model 2 take, let's say, 5 dependency. It can be the user repository and other kind of components. And those components are not supposed to be singleton. By singleton, I mean those objects are not supposed to be a single object that can be reused across the application, but they need to be created every single time we use to use them. So it means that if you have your application with components that require a lot of objects that are not singleton, so it means that you will need to create them several times, and it can be a tricky job. It can be overwhelmed. So that's why it's very important to use the dependency injection framework. A dependency injection framework such as Hilt or Coin will be responsible of creating for you those objects. So we'll just create it once, and as soon as you want to reuse them, you will just request that object from the dependency injection framework. That is really interesting and can save you a lot of time. Another advantage of using a dependency injection framework is the fact that the dependency injection framework will be responsible of managing the life cycle of object. There is some object that need to be destroyed after the life cycle of another object. So let's say you create an object that depends of let's say a fragment or an activity. So it means that all the dependency that has been injected into that view model need to be destroyed if they are not needed somewhere else. And by using the manual dependency injection, it can be quite tricky to be able to manage the lifecycle of all the objects that will be created inside your application. But by using a dependency injection framework such as Hilt or Coin, it will be much more easier to handle the life cycle of all the objects that you are going to create in your application. And in this particular project, in our simple app, we are going to see how we can manage and create all the dependency that will be required in our application using Hilt. As we are going to use Hilt for dependency injection, I think it's the great time to set up Hilt into our project. And when you create your project using the latest canary version of Android Studio, you will notice that project catalog is used by default when it comes to manage dependency. And we are going to follow the concept or the conversion of project catalog in our project. So the first thing we need to do is to find the toml file that contains all the dependencies that are related to our project. And to do that, you need to switch to the project section of your application, and you will find this toml file that contains all the dependency. So the first thing I need to do here is to put the version of Hilt that we're going to use. So I think the latest version is 2.44. So to do that, I'm just create a variable here that I'm going to call, let's say, Hilt version, right? It's 2.44. Great. The second thing that I need to do is to put the Hilt plugin. So I'm going to put it into this Hilt, this plugin section here, right? I'm just going to copy this line. I will replace it by Hilt. Let's say just Hilt, right? And let me replace this ID by the Hilt ID. In order to find that ID, I just need to switch to the documentation. And where is the ID? Okay, here is the ID. Great. Secondly, I need to match this plugin to the Hilt version. So I'll just replace this version here by the one that I created on the top of the file. Great. So the second thing I need to do is to apply the capt plugin. So in order to do that, I just need the full name of this capt plugin that I can find here, right? I will do the same thing. Just copy the ID and add it to the plugin section in the toml file. Right, and I can rename it by doing capt. So the capt plugin is supposed to have the same version as the Kotlin library. So I will just copy this version here, and if you check on the top of the file, yeah, you can see that it corresponds to the version of Kotlin that we are going to use. Great. So lastly, the thing that I need to do is to define or to add those two dependencies. So I'm going to add it to the dependency sections, to the libraries section. So to do that, I'm going just to copy this line, right? I'll replace the first ID with this part of the dependency. Great. And the name is Hilt Android. And I'm going to match the version with the Hilt version that I've created on the top of the file. Great, I will copy this line again for the Hilt compiler. The group is the same thing, but the name is different. The version is the same. So this one is Hilt Android, and the second one is Hilt compiler. Now let's try to reference to this all the information that I've put in the toml file into our build.gradle file. After syncing the project, you will have access to all those dependencies from the build.gradle.ktx file. So let me just open it. And the first thing I need to do is to apply the Hilt plugin. So I'm just copy this line. And the plugin was com.google.dagger. Great. The biggest advantage of using project catalog is the fact that you will have access, you will have the full auto-completion of all the dependencies that you have put in the toml file. So another thing that I need to apply here is the capt plugin that I've put in the toml file. So instead of using that, I can use a shortcut by using Kotlin and capt. So from this point, I can try to sync in order just to have access to this capt plugin that I'm going to use shortly. The project have been synced properly. Now let's try to add the Hilt dependency. So let me go back here and just copy this line. And the first one is Hilt Android, and the second one is the compiler. And instead of using implementation, I need to use capt. Great. And lastly, I need to add the Gradle plugin to this first build.gradle file in order to make all the things related to Hilt to work properly. So I'm just copy this line, and I will use the same thing, com.google.dagger Android. Great. Now we need to sync the project again in order to be able to download everything related to Hilt. Let's do that. The synchronization went well. Now I think it's time to configure Hilt. The first component that we need to create in order to configure or to set up Hilt properly is to create the application class. Well, the application class is the class that represents the lifecycle or my application entirely. So in order to do that, let me just create a class. I can call it as I want, but in my case I'm going to use app, right? And I will make this class to extend the application class. And I can even override the onCreate method. And this class must use the annotation Hilt Android app. By doing that, Hilt know what is the lifecycle of my entire application, and Hilt can be able to track quite easily the lifecycle of the different objects that are tied to the lifecycle of the application. So lastly, I need to refer to this class to the manifest. In order to do that, let me just open the manifest, and I can use the name attribute, and as you can see, I already have access to the app class that I've created shortly. And by doing that, everything should work properly. Now it's time to introduce a new concept, the concept of module. So what is basically a module? Well, an Hilt module is a class that is annotated with the module annotation, and it informs Hilt on how to provide instances of certain type. So in our case, I'm going to create a new module that I'm going to call, let's say, view model module, right? And instead of creating a class, I'm just going to create an object. And like I have said earlier, a module is supposed to have the module annotation. By doing this, Hilt know that this object here is a module and will contain all the instruction that Hilt is going to use in order to create some instances. And another thing that is really important to specify here is the scope. And in order to specify the scope, you need to write something like this. And what does it mean exactly? Well, it means that every single object that will be created from this module will be tied to the activity component scope. So it means that if I create a user view model here, right, and I request or I use that user view model inside the main activity, that particular view model will be tied to the lifecycle of the main activity. It means that that view model or that instance will be created when the view model or the main activity is created, and that particular view model will be destroyed as soon as the main activity is destroyed. And what I'm going to do here is to create a new method that I'm going to call, let's say, provide user view model, and the method will going to return user view model. And the only thing that I'm going to do here is to specify or to return the user view model instance. And as we can see, the user view model doesn't take any dependency right now. And now, as I have put this method here, Hilt can kind of have an information about how I'm going to create the user view model instance as soon as someone requests that object. But it's not enough, right? By just creating this method, it's not enough to tell Hilt that, well, every time the user requests the user view model, you have to call this method and return that particular object. In order to have or to help Hilt to know that this method or the object returned by this method, you can use it to give it to someone or to any kind of component that can request the user view model. In order to do that, we need to use the provide annotation. By using the provide annotation, it means that now Hilt have an idea about there is a new object, right, in my collection that I can use every time the user requests it. And now I'm going to show you how we can request this particular object. So in order to do that, I'm just go back into my main activity, and there is something interesting that I'm going to showcase here. First, I need to mark the main activity as the Android entry point. By doing that, by using this annotation, now Hilt have an idea that I can request every single component or every single object that Hilt can provide inside this main activity. By removing this annotation, I can't be able to, to request Hilt to provide for me an object or something related to that. By doing this, right, I can now create something like this. Let's say user view model. And by using the delegation, right, and specifying the type of the object that I'm requesting, now Hilt have an idea about the user is trying to request the user view model. And as we are already provide the instance of the user view model inside our module, right, by using this instruction, Hilt will know exactly when to create this object and how to provide this object to the main activity. And the particularity of this instruction here, as this user view model is coming from the view model module, and the view model module scope is tied to the activity, it means that this object here will be created as soon as the main activity is created and will be destroyed as soon as the main activity is destroyed. So like I have said earlier, Hilt is a pretty interesting tool when it comes to manage the lifecycle of objects. I think that will be all for this video because I think it's started getting very long. And in the next video, we will try to see how to create some new components and how to make the user view model to take some dependencies. And we are going to see how Hilt can help us to create those dependencies in order to avoid doing the dependency injection manually. So don't forget to like and subscribe if you find this video informative, and I will find you in the next one.